Hello, Mr. Wang, right?
Yeah.
Okay, so yesterday we talked about this problem, yeah? We're given this array of numbers and we want to pick k numbers, and for each number we can pick from the beginning or from the end, right? And we want to maximize the numbers we pick. Each time you pick a number, you can pick from the beginning or the end. There are two choices. So there are k numbers to pick, so that's 2 to the power of k, right? That's too slow. And we also talked about the sliding window, right? If there are n numbers, and we want to pick k numbers, right? So the remaining will be n minus k numbers. So if the sum of every number is s, and if the sum of the remaining is a, so we want to maximize this, right? This is the sum of the numbers picked. We want to maximize this. We want to minimize this a, alright?
Yeah.
Yeah. For example, this one. If the window size is 4, and we move one position to the right, so what happened to the sum?
It will minus a plus e.
Yeah, minus a plus e. So we keep updating the windows, right? The sum of the windows. Instead of recalculating the sum. If we recalculate the sum, that's going to take longer, right? We want to talk about another approach today. It's quite similar. So look, with 1, 2, 3, 4, 5, 6, 1, right? We want to pick 3 numbers. K is equal to 3. We want to pick 3 numbers. So if we pick 0 numbers at the beginning, if we pick 1 numbers from the beginning, if we pick 2 numbers from the beginning, if we pick 3 numbers beginning, look, if we pick 0 numbers beginning, so what else should I pick? How many numbers I should pick from the right?
All of it.
So k equals 3, yeah? So it means that I want to pick 0 numbers from the beginning, 3 numbers at the end. Pick 1 numbers from the beginning, 2 numbers at the end, right? 2 numbers from the beginning, 1 numbers at the end. 3 numbers from the beginning, 0 number from the end, right? So if there are k numbers, there are k plus 1 choice. Am I right? So we can do this. We can brute force this k. 0 number from the beginning, 3 number from the end. So what's the sum? 12. 1 number from the beginning, 2 numbers from the end. What's the sum? 1 plus 6 plus 1, 8. 2 numbers from the beginning, 1 number from the end. 1 plus 2 plus 1, 4. 3 numbers from the beginning, 0 number from the end. 1 plus 2 plus 3, 6. So we just pick the maximum, which is 12. Got it? This is more straightforward, am I right? Yesterday we are minimizing the sum of the subarray. But this subarray is the remaining. So we need to minimize it. And we use the s minus the minimizing the sum. Then that will be the sum of the numbers we pick. Yeah, s minus a. We want to minimize this bit. But now we are directly calculating the sum. So we are maximizing this. I want to calculate the sum of these. This array is not changing, right? We want to be able to calculate the sum of first 1 number, first 2 numbers, first 3 numbers. And we want to be able to calculate the sum of last number, last 2 numbers, last 3 numbers. So what comes into mind? Can we calculate this? So we use the accumulate, remember? We use the prefix sum. The sum of the first element is 1. The sum of the first 2 elements is 1 plus 2. 1 plus 2 plus 3. We are pre-calculating the sum. Right? And then we talk about this accumulate function, remember? Accumulate. Yeah? So when we accumulate, look, this is array. When we perform this accumulate, what does it become? This is array, right? A equals this. If we perform the accumulate, so you become 1, 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4. So that's what the accumulate is. So why this is useful? So we can just look it up, right? What's the sum of the first 4 numbers? We just look it up. It's this value. We don't need to calculate when we need it. 1 plus 2 plus 3 plus 4, because that's going to take longer. We look it up, yeah, because we know already. When we calculate the prefix sum from the left to the right, we know the number, yeah? We know the sum. We can have this running sum, right? Now current sum is 0. The current sum plus 1 is 1. Current sum plus 2, plus 3, plus 4, plus 5. Okay, so the other problem is we know how to calculate the sum of first few numbers. How about the sum of the last few numbers? Yeah? Think about it. Okay, we know, okay? Sorry? Minus, exactly, yeah. We know all of it. And then we know the first few numbers. The sum minus the few numbers is the remaining. Define max point array A, and we want to pick k numbers. First of all, let's get the numbers. How many numbers? And accumulate. We want to have this prefix sum. Accumulate, yeah. So prefix sum equals accumulate A. We want to convert it to a list because accumulator returns an iterator. Iterator is not a list. It's like what's iterator? The year thing, yeah. So I promise you to give you at least a few numbers, but I'm not giving you all at once. When you ask for it, I give you one. When you ask me for it, I give one. When we put this list, we convert it to a list. But at the beginning, I'm going to put a 0 at the beginning. Okay, so look, 1, 2, 3, 4, right? So when we do this accumulate, you become what? Can you tell me? 1, 3, what? Come on. Fill the blanks.
6, 10.
6, 10. Okay, we're done. I want to put a 0 at the beginning because we want to pick k numbers. As I said, there are k plus 1 choice. So how many choices is this?
4.
Okay, so there are k plus 1, right? So I put a 0 means that if I pick nothing from the beginning, we need to brute force all these k plus 1 choice. Yeah? For I in range k plus 1, right? We need to do this sum as well. Sum will be everything, yeah? Sum of everything, sum A. That's going to take O n time, right? Look, we iterate k times here, but that's going to take O n time. So what's the time complexity? Look, there are n times here, there are k times here, so the time complexity is O n. K is smaller than n, so O n, okay? The sum, the current sum, the C, okay? C equals prefix I plus the overall, we pick here. So if we are fetching the value here, if this k equals 3, we pick nothing from the beginning. So we need to pick 3 numbers from the end, right? So how many numbers? N numbers, right? So now we need to pick k numbers, and then we pick nothing at the beginning. So how many numbers left? K minus I, right? And then from the end, because we are adding a 0, so the last value will be n. The index here will be n. So it's n minus this, right? So n is p n minus k minus I, right? So, but we need to subtract these from S, right? Look, this is total sum, right? This is the prefix sum. So we do this subtraction. That will be the sum of the last few numbers, right? And then we just have to get the maximum. Answer equals maximum of answer C. Return answer. Answer at the beginning is 0. Okay. Some people might be able to write this using this one number. This is not mandatory. I actually prefer writing it in a very clear way. So, okay, what's new today? What have you learned?
Learned about maximum points you can obtain.
What's the problem? And what did we talk? How many approach have you learned today? What's the algorithm we learned today? How is it different than the one yesterday? Than the one we talked about
It's a
yesterday?
different algorithm.
Okay, so what's the two approach? What's the difference between these two approach?
That one has accumulate.
Accumulate. What's accumulate?
Accumulate is basically like 0, 1, 3, 6, 10.
What is the meaning of the accumulate? This word. What does it mean? Accumulate in English.
I don't know.
The everyday thing accumulate. Accumulate. Put it all together. Little by little.
Accumulate.
Yeah. Accumulate, you can, in Python, accumulate is basically like prefix. Do you still remember why we need to do this accumulate? Look. Okay, what's the sum of 2 plus 3 plus 4?
9.
Okay. We are given this array, right? We want to calculate the sum of any intervals. Right? How would you do it? The normal way would be You just calculate 2 plus 3 plus 4, right?
Yeah.
Okay, so look, if consider, listen, consider this is a very big number, 1 to a million. Okay? 1, 2, 3, 4, a million. I don't know, okay? Yeah?
It's 100.
I know, could be many. Let's say I want to calculate an interval somewhere. For example, I want to calculate from 2 to a million minus 1. How would you do it? The stupid way would be just 2 plus 3 plus 4, right? You're going to take forever, right? But how would you do it? If I'm saying this array is not changing, look, how about accumulate, prefix sum? So look, I calculate 1 plus 2, 3, 1 plus 2 plus 3, 6, 10, etc. Okay? So taking this example, so this number will be, prefix sum will be 1, 3, 6, 10, 15, 21, okay? And what's the sum of 2 plus 3 plus 4? Is it equals to 1 plus 2 plus 3 plus 4 minus 1?
No.
Yeah?
Yes.
Okay, so 1 plus 2 plus 3 plus 4 is 10. Okay? What's the sum of up to 1? Is 1. So what's the sum?
9.
10 minus 1. But this array I calculated once. So I can just look it up. Look it up two values. Look it up two values and do this subtraction. Right? Is it quicker? Looking up, is it quicker? Yeah? Okay. Okay, so let me repeat. Yesterday we talked about these using the 2-pointer sliding window thing. Because we want to maximize S minus A. A is the sum of the remaining numbers. Right? We want to maximize this, so it means that we need to minimize the remaining numbers. Am I right? For the remaining numbers, we use the sliding window to keep updating the sum of the window size and minus k. Right? That will work. Today, we're talking about a different approach. To pick k numbers, we have k plus 1 choice. Picking 0 numbers from the beginning, picking 1 numbers from the beginning, picking 2 numbers from the beginning, picking k numbers from the beginning, 0 to k, there are k plus 1 possibilities. For each possibility, we can use the accumulate prefix sum to get the sum of the first few numbers, right? That's easy. We're doing this lookup. But we also need the sum of the last few numbers. In order to do that, we use the subtraction, right? We know the sum of all the numbers. We just need to minus a few numbers, then that will be the sum of the last few numbers. Am I right? Okay. Okay, and then the time complexity, look. Accumulate on time, space on space, sum on time. So it's on plus ok. Okay, so that's on time. Space complexity, we're using the accumulate prefix array. So that's going to take on space. Okay, that's it for today. Bye bye.
Bye.
Bye bye.
Bye.